introduce our second keynote in the second day of ONTOBRAS. It's a keynote entitled ISO/IEC 21838 as the basis for a sustainable ontology development strategy. So it's about this ISO/IEC top-level ontology standard. And our keynote speaker is Professor Barry Smith. He is a distinguished professor at the University of Buffalo in the US in areas that range from philosophy to computer science, neurology, and bioinformatics. He requires very little introduction in this area. He's the father of BFO and of the Obo Foundry. He used to be a philosopher, and you know, that's philosophy's lost hour again. And I say that honestly, not only because he got more interested in building artifacts, so in having an engineer mindset, but also I think he did a tremendous service to the area of ontology in teaching ontologists to think like engineers in the sense of, you know, catering for the entire life cycle of these artifacts that we build, that it's not enough to have a good theory or a good model, but we should think of, you know, having a product service system, thinking about education, books and tools and an entire community. And I think, you know, that really contributed to making ontology much more well-known outside academic circles. So for those of you that joined the community later, you might not know this, but Barry Smith was the keynote speaker at the very first ONTOBRAS in Niterói in 2008. So it's great to have him back here. Thank you very much for accepting this invitation. It's great to have you here, Barry.
Thank you, Giancarlo. I'm very pleased to be here. And as we were saying before, we're not quite sure where here is, but still, I'm here. Now, ISO IEC 21838 is a new ISO standard. It will be a multi-part standard, and part one has already been released. I will be describing the other parts or the other potential parts of the standard, and also a further standard relating to mid-level ontologies. And so part one will be about 21838, the top-level ontology standard. Part two will be about specific features of the BFO part of ISO IEC 21838, particularly in regard to the treatment of time. And part three will be about mid-level ontologies. And I noticed that this the screen every few seconds it gets this thing at the top. Is there any way we can stop that? Anyone knows how we make it stop?
You mean this green thing that?
No, I'm seeing a black thing pulled down now. It's just pulled down. Do you not see that?
No.
No.
Okay, good. Then I'll ignore it. All right. So, and then the final part will be about mid-level ontologies, and that too will be, we hope, a new standard. But we're at the very beginnings of that, and so we have a standards committee for mid-level ontologies, but no actual standard to point to. Okay, so ISO IEC means the Joint Technical Committee of the International Standards Organization and the International Electrotechnical Commission. And this Joint Technical Committee is interested in standards for things like MP3 and MPEG-2 and so forth. In other words, standards for joining various parts of information technology so that we have successful interoperability. And various groups behind this Joint Technical Committee came to the realization that it would be a good idea if we could have a standard for top-level ontologies. The idea being that ontologies too should enjoy some of the benefits of interoperability, and that we can achieve these benefits if we standardize what it is to be a top-level ontology, which is what part one is all about, and then standardize certain top-level ontologies by showing that they satisfy the requirements of part one. And BFO is the first of the top-level ontologies which has been standardized in this respect. And you can find the web page for part 1 at the link there. That part 1 has been completed, approved. The proofs have been corrected. And as I understand it, the document itself will be free. So most ISO standards, you have to pay for them, and they belong to ISO. These standards, again, as I understand it, are going to be in the public domain. And the basic idea behind the standard is that ontologies increasingly are being created as suites of ontologies in a hub and spokes kind of arrangement, where you have a top-level ontology which forms the hub, and then various extensions of this top-level ontology are built by downward population from the hub. That means that the terms in the extension ontologies start by defining children or subclasses of terms from the top-level ontology. And then we eventually will have spokes of spokes and spokes of spokes of spokes, so that we get a gradually developing suite or system or collection of ontologies which are organized to be interoperable because they all use the same top-level hub. So this is the idea behind ISO 21838, and it's the idea behind BFO. It's been the idea behind BFO from the very beginning, since BFO was in fact created as part of an attempt to create a suite of ontologies in the biomedical field. In 2002 or thereabouts, we started talking about the need for such a suite of interoperable biomedical ontologies, and it became clear that we needed a top level to organize this suite, and BFO grew out of that effort. All right, now, without this kind of organizational hub and spoke structure, we have problems, and we can illustrate these problems by looking at the way W3C deals with its standard ontologies. So there are two W3C approved high-level ontologies, if you like. There may be more, but these are the ones I'm going to deal with. The provenance ontology looks a bit like this. So it's about revisions, and it's about activities which create entities, the provenance of which we want to track. And the provenance ontology has upper level terms, which are listed here. And then there is the semantic sensor network ontology, which is about networks of sensors. And the organization looks something like this, and it too has a top level. And the top level here contains completely different terms from the top level of the provenance ontology. And that obviously is going to make it very difficult for people to combine data about provenance with data about sensors, when the whole point of the W3C was to bring about interoperability between people who are using semantic technology to organize their data. And so the W3C does not understand the need for a common top-level hub to create greater interoperability among the ontologies which the W3C standards were designed to support. So the first job in formulating ISO 21838 Part 1, which is requirements for being a top-level ontology, is to define what it is to be an ontology. And we use the word collection here. That word is used for a quite specific reason. A collection can change over time and still be the same collection. So you can have a stamp collection or a coin collection or a model train collection, and your collection can grow bigger and you can sell parts of it. It's still the same collection. This means that OWL 2, for instance, can, if we want to speak in this way, can be the same ontology as OWL 1, because they are both collections of terms which we then view as being the same collection over time. And that is necessary because most of the important ontologies which are used and reused change over time. And so this is why we use the word collection. So we are not, in other words, viewing an ontology as a set of terms and other expressions. If we viewed it as a set, then the ontology could never change. And that is, as I say, very important when we're trying to keep track of successive versions of ontologies and so forth. And then the definition of top-level ontology is just that it's domain neutral. And Aristotle used the word category to refer to the highest level species and genera within his term hierarchy. And so we use the term category in the standard as the name for those terms which are domain neutral. Terms mean expressions referring to classes or types, and then there are domain specific classes or types, and you can generalize those until you get to the very top, and then you have domain neutral classes or types like object, process, quality, and so forth. And now the reason why we use class or type in this way is because the 21838 standard is deliberately neutral as between semantic web OWL W3C jargon, which uses classes, and the jargon used, for instance, in the OBO Foundry, which uses type or sometimes the word universal. And the OBO Foundry is a very successful application suite of ontologies. It has many, many, many users, and for this reason, it has some kind of significance in the space of ontologies which we are trying to standardize by creating this 21838 standard. All right, now, to be a top-level ontology, you have to be maximally neutral. So that means you shouldn't have terms which refer to domain-specific things like tables or planets or temperature. And you should cover everything. So there should be no part of reality which is not covered by your ontology. And so you could, in principle, have just one term in your ontology, such as the term everything or entity or thing. So thing is certainly a domain in the W3C OWL sense of thing. It's certainly a domain neutral term, and it certainly covers all entities, but it's not really a very good ontology. And the reason it's not a very good ontology is because it doesn't give us a clue as to how we should deal with data at lower levels. And that's the point of an ontology. We want the hub to organize the domain ontologies, and just one word thing will not do that. And so we solve this problem by making a ruling that any ontology which wants to be a top-level ontology satisfying the requirements specified in part 1 has to explain how its terms will support dealing with data about things like this. And so we have something like 15 boxes of issues relating to space and time, relating to time and change, relating to scale and granularity, and so on. And to be an ontology which satisfies the requirements of part 1, you have to explain how you deal with data using your ontology about all of these things. And then there were other requirements. You have to have English language definitions. You have to have an OWL axiomatization. You have to have a first-order logic axiomatization, and you have proofs of consistency and derivability. All right, now this is part 2. Part 2 has been approved. The proofs have not been corrected yet. So we're not quite at the final stage, but there are very few steps which we need to go through, and it's a matter, I'm told, of days rather than weeks before part 2 is approved also. And part 2 is BFO. So it explains how BFO satisfies all the requirements, both in terms of coverage and in terms of generality and in terms of logistics, so how it's maintained and so forth, which was specified in part 1. And part 2 too is going to be, as we are told, in the public domain, completely free. And you can look at BFO 2020, which is the version of BFO which it was created in order to match the requirements of the standard in part 1. You can see these currently at the ISO standards maintenance portal. They will also be available at the BFO developers group portal, the link to which I will provide later on. And then there are 2 more standards which are in earlier phases of review, or 2 more potential standards. Part 3 is Dolce, which I've never heard of, but I believe it comes from somewhere in Middle Europe, and Tupper, which I think you've all never heard of. This is an ontology developed by Michael Gruninger and his group around the common logic community. It's a very new ontology, and with luck, it will be the 4th ontology to be the 4th standard to be approved within the 21838 multi-part standard. All right, so I've talked about the hub and spokes approach. Now, there is this paper which considers the idea that perhaps there should be one hub. Now, of course, I would vote for BFO to be that one hub. And this paper is about the question, should we just have one hub or should we have multiple hubs? It's a very interesting paper. And it points out, first of all, that BFO has been developed primarily for biomedical ontology interoperability, which is true. And then it points out that of all the ontologies in the linked open data cloud, BFO is actually the only ontology which is being reused by other ontologies. Now that is because we've been very successful in the biological field. And so this is a list of something like 350 domain ontologies which extend BFO. I think probably around 300 of them are indeed biological, but there are non-biological ontologies which are being developed, and that is increasing quite rapidly, as I will show you in a minute. So the LOD cloud has this red area in the bottom, which is biomedicine, life sciences, and BFO is connected to practically all of those things. So this is BFO, this is all the other things around it, and you can see that this is the dark area within the cloud, because that's the area where people are really working interoperably. They're actually linking to each other successfully and consistently and ontologically, rather than just randomly and subjectively, which is what you have in the other parts of the cloud. So we're doing something right down here in the red area. And this is shown by this paper on the bioportal, which is Mark Musen's repository of primarily life science ontologies, where BFO turns out to be the most reused ontology of all the biomedical ontologies, and of all ontologies which are reused in the biomedical ontologies. We also have a textbook, and which was just translated into Chinese, and the Chinese publication appeared last week. So if you have any Chinese reading members of the ONTOBRAS community, then you can now read the textbook in Chinese. And there is this paper which started the OBO Foundry in 2005. The OBO Foundry that's the name of this suite of biomedical ontologies, of which BFO is the hub. And we've seen that. This is BFO 2020. It differs very little from BFO 2.0. So there are certain changes. For instance, we have two new terms, temporal instant and temporal interval. We have two new relations, first instant of, last instant of, regarding time. And then there are one or two similar changes. We have fiat point, fiat line, fiat surface, where before we had zero-dimensional fiat spatial region or something like that. So we've changed in very minor ways and really just cosmetic improvements. But there are some more serious changes, which I'll describe in a minute. Now, already this standard is having some impact. So there are other ISO standards in development which are already using 21838-2. And there are now quite a number of engineering ontologies which are using BFO as the basis for, in some cases, re-engineering of existing engineering ontologies to take advantage of the fact that BFO gives you interoperability with other ontologies in the way that I've been describing. We also have a number of efforts to use BFO in the military and intelligence field, including a very important effort in this interesting organization, which is the Joint Artificial Intelligence Community, Department of Defense and Intelligence Community, sorry, the Joint Artificial Intelligence Center, Department of Defense and Intelligence Community Ontology Working Group. They have established a foundry, an ontology foundry, to enable interoperability across the military and the intelligence in the US. And they are using a BFO suite of ontologies as organizing principle for that suite of ontologies. And so this is the Industrial Ontologies Foundry, which is a similar suite of ontologies created initially within the auspices of NIST, which is the National Institute for Standards and Technology in America. And then there are a number of ontologies for industry which are being developed or which have been developed. And that ends the story about the use of BFO. And now I'm going to give you a very quick introduction to BFO itself. So basically, it's similar to UFO and to this other thing called Dulce. We divide the world into continuance and occurrence, which are sometimes called endurance and perdurance. And then we have independent continuance and specifically dependent continuance, and then we have instances of all of those things. So I hope that's not new. And then we have realizable dependent continuance. And the important ones are dispositions and roles. And the idea is that realizable dependent continuance are always realized in certain processes. And then we have the material basis for a realizable dependent continuant is some part of the bearer, which is, in the case of a disease, it's some part of the bearer which is disordered. So the material basis of cancer might be a disordered or a carcinomatous liver, for instance. And then we have therefore we have two kinds of specifically dependent continuants, the realizable ones and then the non-realizable because already realized ones. And they are called qualities and quality patterns in BFO. And the two are related to each other, as we will see. And then we have generically dependent continuants, which are things like information entities and gene sequences and protein sequences and so on. So the PDF file on my laptop is a quality pattern, but the PDF content, which I can copy to your laptop, is a generically dependent continuant because it can have more than one bearer. It can migrate from one bearer to another. And these are examples of some generically dependent continuants. Plans and laws are generically dependent continuants, and plans and laws and all the other examples are in every case concretized in specifically dependent continuants, which are quality patterns. For instance, patterns of ink or patterns of neuronal clusters inside your head and so on. So this, I think, is clear. This is clear. In every case, we're going to have some bearer of the genetically dependent continuant, which will be a material entity. It might be some part of your hard drive. It might be a collection of papers bound together to make a book. And then the information artifact is concretized by this quality pattern, which specifically depends upon the information bearing entity, which could be a copy of War and Peace. This is a definition of the information content entity, which is that which gets copied or communicated or recorded when you create an email or a report or a document of any kind. And so I've said this already, all of these generically dependent continuants are concretized in specifically dependent continuants. And any given generically dependent continuant can be concretized in many specifically dependent continuants. So this bill of materials in PDF format is concretized either in this PDF format on my laptop or in this PDF format on your laptop. And then War and Peace is a specifically dependent is a generically dependent continuant, which is concretized in the War and Peace quality, which is the quality created by all the little piles of ink on all the pages of any given copy of War and Peace. And so the copy is an instance of independent continuant. It's a material entity. The War and Peace quality is an instance of specifically dependent continuant. And the novel itself is a generically dependent continuant. You cannot buy the novel War and Peace. You can only buy a copy. And this is a part of an ontology of intelligence documents built around the information artifact ontology, which is a BFO extension ontology for information entities. And I won't go into this anymore. It's pretty clear from what I've said. So there are various tests that you can use, whether you're dealing with a generically dependent continuant or with a specifically dependent continuant. And the tests have to do with pluralization. So there cannot be two copies of the US, there can be two copies of the US Declaration of Independence because that is an independent continuant, but there can't be two US Declarations of Independence because generically dependent continuants are necessarily unique. They're not copyable, even though they exist because specifically dependent continuants are copyable. All right, and yes.
Sorry to interrupt you, but there is some problem with the camera. We can only see your hands and your chest. So maybe if you can represent.
I see. Yeah.
Okay, better now. Thank you.
Sorry that I don't know how that happened, but all right. So there can be three people, but there cannot be three Michelle Obamas. And another key rule for distinguishing generically dependent continuants from types now is that they have a quite different kind of provenance. So generically dependent continuants in the realm of information content entities have a provenance which relates to the fact that they are artifacts created by people. So aspirin as a product of Bayer is a generically dependent continuant. Aspirin as a molecular structure is a specifically dependent continuum, which is repeated over and over again in specific tablets and in specific preparations. And aspirin as a molecular structure came into existence much earlier than aspirin as a product of Bayer GmbH. Okay, now we're going to move to BFO 2020. So all that I've said so far is pretty much applying to BFO 2.0. BFO 2020 has two parts, BFO 2.0 plus a whole series of logical improvements, which came primarily from Alan Rothenberg, who is in this fuzzy photograph here. And you can see details of these logical improvements in the slides at this link. And so first of all, he created a common logic formalization and more, which has some 300 and plus axioms. And he also created a consistency proof, which was a kind of miracle. And the point about first order logic, common logic, is that it's much more expressive and more intuitive than OWL, for instance. And so you, in a way, you can do more ambitious things with common logic and first order logic, although because they're not quite so tractable when it comes to computation, there are still reasons to keep the OWL version of BFO 2020 alive. And we created two OWL versions. One is the simple OWL version without what will be called temporalized relations. And then there is a version with a full set of temporalized relations, which I will describe in a minute. That's the really new part, which was also a contribution from Alan. And then we have a definitive set of natural language definitions and examples. That these are very close to what we had in BFO2, but they are much more careful, much more carefully formulated and more systematically formulated than in any earlier documentation. All right, now I said that the temporal theory is extended by adding first instance of and last instance of. We also add a temporalization for concretizes, and I'll explain why in a minute, and for is a carrier of, which is the relation between, for instance, the copy of a novel or the pattern of ink in a novel and the generically dependent continuum, which is the novel itself. That we have a much more regimented understanding of temporal and spatio-temporal relations. So it's as complicated as this, but every single one of these relations is in fact very simple and very intuitive. It just looks complicated when you put them all on one page. So every spatio-temporal region exists at some temporal region, which is the temporal region, which is the extent, the entire extent of the spatio-temporal region with which you start. Every process occupies some spatio-temporal region. So these are all very simple relations, but to put them all together makes them look complicated. And we've already seen this slide. And now what we realized is that the relation of concretizes here between, for instance, war and peace and some pattern of ink has to be temporalized. So we didn't temporalize it in BFO 2.0. And this is because of cases like, well, this is illustrated by cases like this. So there are a lot of people on this football field which are doing the kind of thing that people do in Texas, namely create big shapes. And this aggregate bears the shape of the logo of this football team. And the aggregate can move around and the shape can change. And so it's the same generically dependent continuant, even though the shape changes. And in order to do justice to the possibilities here, we have to allow the concretization relation to be temporal. In other words, it holds between a given material entity, which is here an aggregate of persons, and the quality pattern which that aggregate of persons forms differently at different times. Another step which we think is an improvement between BFO 2020 and BFO 2.0, is in the treatment of object aggregates. So there is a puzzle when you have a two-person organization. When one member leaves, does the organization cease to exist? And we say, no, it does not cease to exist. Where before we would logically have to say that it did cease to exist, because object aggregates are in BFO 2.0 always such that they have at least two members. That is no longer the case. That the rule is that you have to have at least one member, but you have to have more than one member at some time. So you can't be an object aggregate until there is some plurality of members, but if most of them leave, the object aggregate may preserve its identity. All right, now the really important part is the treatment of time in BFO 2020. And here I think that Alan has created something which is unique, and it's a solution to a problem which no one else has really solved. So Giancarlo's brain, which I see I've misspelt on this slide, I called it Braum, but never mind, is always a part of Giancarlo. Whenever Giancarlo exists, Giancarlo's brain exists. This is permanent specific relatedness. Every human has some brain, but since we don't know how to what do we do when we transplant? We don't know how to transplant brains. And so if you have a brain, then you have the same brain at all times. So there is this relation, has part at all times, which holds between Giancarlo and his brain. This is a very common relation. Practically all parthood relations are at all times relations. Now there is another temporary relatedness which holds between Giancarlo and his milk teeth. So Giancarlo exists and does not have any milk teeth, but nevertheless, it was true for a certain time early on in Giancarlo's life that he had milk teeth as part. So this is another relation. It's different from the permanent parthood relatedness that we saw on the previous slide. And now there is a third relation, which is called permanent generic relatedness. And now this is a more complicated relation and which occurs very seldom. So most parthood relations do not have the problem illustrated here, but some of them do. And if your ontology does not deal with this fact, if it has no way of dealing with this fact, then it is an ontology which is liable to have logical problems. So every portion of skin tissue in your body contains some portions of keratinocyte, which we'll just call K-site. You always have to have K-sites in your skin. The problem is that at some times in your life, the molecules of K-site are different from at other times. So your skin tissue exists throughout your life, but one specific molecule of K-site exists to fulfill the need that your skin has for K-sites only in a certain part of your entire life. And in the other parts of your life, it's different K-site molecules which fulfill this need. Now, at every time, we have a very simple relation. Your skin tissue X has part K-site Y1. There is no problem at the level of instances. But at the level of types, if we say every portion of skin tissue has part K-site, without at every time, then there is an ambiguity. Do we mean has the same K-site part, or do we mean, as is correctly the case, that you always have a K-site, but it's a different K-site at different times? And in the first order logic, we can translate these into formulae which capture the differences. And we don't need to go through this, but the third one allows for a change of part. And the OWL normal view of things can translate very easily the first case, the permanent specific relatedness, the second case, the temporary relatedness, but in OWL, you can't capture permanent generic relatedness. At least you couldn't until we put forward BFO 2020, which contains a way of capturing this permanent generic relatedness. Now, as I say, this problem is rare. Most biological parthood relations do not have a failure of transitivity. It's a very, very select few. And the problem doesn't arise at all if you're using first order logic. It only arises when you use OWL or some other language which restricts you to two-place relations. So it doesn't arise only for part of it, arises for location and for many other relations. So this is a problem which can in principle arise anywhere in your ontology and have nothing to do with parthood. So what we do in order to solve this problem in BFO 2020 is we incorporate a new set of two-place relations which provide the template for dealing with it in I won't say every case, but very many of the cases which we face in doing ontologies. So we define a new kind of two-place relation, which is the at all times two-place relation, as follows. To say that B has part at all times C is to say that if B exists at any time T, then B has continuant part C at T. So we're defining a two-place relation in terms of a three-place relation. OWL doesn't care about the three-place relation. It doesn't care about the definition. It's just going to use the defined relation stated there. And similarly, we have an at some time C relation, which is a weaker relation and which is not going to allow you to make assertions of transitivity. So if you can say at all times, then you can assert transitivity of parthood, which is what you want to do. And this is what this is all about. We want to be able to assert transitivity. If you can only say at some time, you cannot assert transitivity. And so in order to say transitivity, we must check whether we are correct to use the at all times relation when we express parthood axioms. If we know that we're dealing with a kind of parthood where transitivity can hold, where transitivity always holds, then we can just use part of. But if we're dealing with a kind of parthood where we do not have any authority to believe that transitivity holds, then we have to use part of at all times for those cases where it does hold, and then part of at some time, or just no assertion at all for those cases where it doesn't hold. All right, so a biological example we've already seen. And now let's look at a manufacturing example. So we may have a widget, which is part of some machine during the assembled phase. In other words, when the machine is built. But in the pre-assembled phase, it's not necessarily going to be a part of the machine. And this is a case of transitivity, but you can see how we're going to very easily end up with cases of non-transitivity when we look at machines in process of being assembled. For instance, machines which have been repaired when you take them apart, for instance, or where you take out a certain part and replace another part. And so this is the kind of situation that we will be dealing with. All right, so the pros of BFO 2020 in OWL now are that it has these well-defined temporal relations wherever they're needed. And it works for non-rigid types. It works for roles, for instance. And we believe that this is a more elegant approach to solving this transitivity problem, which we were the first to identify. And with that, there are other ways of doing this, but no one is sure whether they really work in OWL, so that they are still at an earlier stage of testing. And the cons are that if you're going to deal with things like milk teeth, then you have to create part relations for specific phases in the life of the organism, and comparable part relations for the specific phases in the life of, for instance, a manufactured entity. All right, now I'm going to finish with some slides which were compiled by a colleague of mine in Buffalo, Ron Rudnicki, on the topic of Common Core Ontology. So I've been involved very much with Ron's work from the beginning on this topic. And so I'm just using his slides for convenience. You will see that his slides are much better than my slides in all kinds of ways. And I think that some of what is discussed in these slides is going to be interesting to the audience, and so I didn't want to miss the opportunity. So I mentioned that there was a standards effort for mid-level ontologies, and it's very much in the spirit of ISO 21838. The committee involved is an American committee, which is a feeder committee to ISO. So some of the standards developed by Insights become ISO standards at a later stage. And so we've created an ad hoc mid-level ontology working group, and it's creating a cyber ontology as a test case. But the Common Core Ontologies are going to be the presumptive framework of mid-level ontologies, which will be developed by Insights as its proposed mid-level ontology standard. There may be multiple suites of mid-level ontologies in addition to the Common Core Ontologies, which end up being standardized in the same way that there will be multiple top-level ontologies standardized under ISO 21838. But for the moment, we're working with Common Core Ontologies. And these were created during an IARPA challenge program some years ago. They were very successful in meeting the challenges of this program. And when I say they, I mean Ron and his team who developed the Common Core Ontologies. And the goal of this challenge program was to create a strategy which would enable you to search through large amounts of random data very quickly. And the challenge was to, given the data, within a few hours, you had to be able to answer questions that you'd never seen before, and you'd never seen the data before. And so you had to have a way of dealing with data which was very general, and hence the Common Core Ontologies were conceived from the beginning as a very general suite of ontologies covering data of many different kinds. And so the original scope was determined by working downwards to see what the very next term would be when you get to the leaf nodes of BFO. And so physical object would be the next term down after the BFO leaf node independent continuant, and place would be the next leaf node down after you deal with BFO site, and so on. And so you end up with a picture like this. So an event ontology, a quality ontology, an agent ontology, and so forth. And you'll see that we have BFO at the top, and then we have a relation ontology, which is imported from the very large collection of relations in the relation ontology, which was created by the Obo Foundry, which is much too large now. You will also see in the top right-hand corner something called the modal relation ontology, which I'm very interested in showing to you, because I think this is also an original and unique contribution. And so you can see how they're divided: time and place, attributes, physical objects, processes. And there are many, many different users of the Common Core Ontologies, at many different uses of the Common Core Ontology. So the cyber and sensor domains, the space mission domains. So you'll see that there is a sort of tilt in the direction of what might be interesting from the point of view of the military. But the Common Core Ontologies themselves are all free and open source. What happens is that we have domain ontologies for things like military planning, which are not quite so freely available as the Common Core Ontologies themselves at the top here. And now the way the Common Core Ontologies are used is one way is by taking large databases. So yesterday I talked a little bit about the large number of government repositories with catalogs and taxonomies attached to them. So we take data of that sort, and then we use the Common Core Ontologies in order to tag the column headers in such data tables. And this turns out to be a very efficient way of acquiring semantically enhanced data for various purposes. And so in principle, we can do this to create ontologies of the data that we have at very high levels using a tool called OSCAR, which creates ontology chains semi-automatically from raw data. And now there are various problems which arise as soon as you start using a highly general mid-level ontology in this way. So attributes change over time. How do you deal with things like ages? People get older, and so how do you deal with that in such a way that you always have data which is up to date and correct? And then there is a problem of keeping track of provenance. How do you know where specific kinds of data come from? And you also have a big problem, which is what I want to deal with in the final couple of minutes. So BFO is a realist ontology, as contrasted with the famous Dolce, which everyone knows about, which is an ontology which deals also with non-existent entities, such as Nicola Guarino's 14th daughter. And BFO does not want to deal with non-existent entities because it wants to be a realist ontology. But there are entities in the world which are very important to BFO, which deal with non-existent entities, and they are, for instance, plans and designs. And BFO does not want to be in a position where its ontology cannot deal with plans and designs. And so we're going to see how BFO can deal with plans and designs by looking at the modal relation ontology. So we've talked a little bit about the problems which arise when entities are dealt with over time, for instance, when they age. And I'm not going to deal with this because it will distract us from what I really want to deal with. But let me just mention the idea of stasis. So when Abraham Lincoln is president, then he has a president role. And this president role occupies a certain temporal interval. And so we reify the president role in order to be able to assert that Abraham Lincoln was president at a certain time. And this turns out to be a very valuable way of dealing with the problems which arise as a result of the fact that people can change. This idea of a stasis is a very boring process. It's a process which does not involve any change. And other people use the word state, but the word state means so many different things to different people that we found that using an odd word stasis and defining it very carefully as a process, a kind of process, just a flat process, if you like, is more useful. And we won't talk about literals. We won't talk about the way CCO deals with provenance. We won't talk about the ways provenance are recorded because we want to talk about non-existent entities. Or rather, we want to see how we can deal with what people think they are doing when they think they are talking about non-existent entities within a BFO CCO framework. And so we're going to look very quickly at designed artifacts, predicted outcomes, and reference of false statements. And what we want to do, we want to stick with realism. So we shouldn't be able to infer from anything that we say anything that is false. And we don't want to be able to infer from anything that we say that some non-existing entity exists. But we do want to make it possible to compare actual entities with what look like non-existent entities. And an example would be, we have an aeroplane which was built to a certain specification, and the aeroplane is delivered and it flies. But when they fly it, it proves not quite to satisfy the specification. It's heavier or slower, or there is some difference. And so the airplane as specified in the requirement specification on the box is not exactly the aircraft that is actually on the field about to take off. And so this distinction between the desired specifications and the actual specifications is very important in manufacturing. So how do we allow comparisons between actual entities and putative non-existent entities? So that problem is solved by the modal relation ontology. And what the modal relation ontology does is the following. We create a copy of all the relations in BFO and CCO, but it's a different relation with a different namespace. And when we use relational expressions from the modal relation ontology, then the ontological commitment to the existence of the reference of the corresponding statements goes away. So we can make all the comparisons that we want, and we create sentences which look very much like sentences about real objects. But because we're using the modal relation ontology, we cannot infer that those real objects exist in the way that we can always infer that they exist when we use the plain vanilla relation ontology, of which the modal relations ontology is a copy. Now, this is a very simple idea. It allows you to understand what's going on in designs. The relationship between a design and the designed object is very similar whether or not the designed object ever gets built. So in other words, when we're talking about the relationship between the design and the designed object in the case where a design is never ever realized, which is in most cases, and the way we talk about that relationship when the designed object really does get built, which is when you're really successful, they are similar kinds of talk, but there's a big difference. We can't infer the existence of the designed object, the product, in the first case, and we can in the second case. All right, and so this is how we represent plans using the modal relation ontology. And you can just see MRO everywhere. And we can talk about testing of the artifact, which is the result of the plan, even if the testing never occurs. And this is the way we deal with the difference between actual events and planned events, which is also a comparison of the sort which, for instance, military organizations are making all the time, because they want to plan in such a way that they follow the track which led to success rather than the track which led to failure. And so that is the end of my plan. No, that's not quite the end. I don't think I want to talk about that. Yes, I'm just going to finish here. These are some of the people who are either using the Common Core Ontologies or reviewing it for purposes of use. So the Industrial Ontologies Foundry, which I talked about, they are using it in a big way. And some of the other manufacturing organizations mentioned here are supporting the Industrial Ontologies Foundry, and so they are using it also. And with that, I will stop. So I hope you're all still there.
Okay, thank you very much, Barry. By the way, we still have a problem with your camera, and we still only see your chest. Okay. Now...
I must have this tick to pull my screen towards me, but anyway. I will now get rid of this slide so that we can see each other, as it were. In fact, I'll stop sharing.
Yes, yes,
good.
That's fine.
Now I can see where my head is.
Good. So I think I'll give people time to reflect on your talk. Thank you very much for this very informative talk. And I'll start asking some questions myself. I of course have many questions, but I would like to make a comment first, which is about, what you mentioned about these different types of parthood relations with generic dependence and specific dependence and so on. We have that in UFO as well for quite some time, actually, that we have this, we call this the essential parthood in the case of parthood plus specific dependence, mandatory parthood for parthood with generic dependence. Then you have that from the part to the whole as well. So for example, it's not only the case that I have my brain necessarily, but my brain, it's part of me necessarily. So it's also specifically dependence from the part to the whole as well. And we also have this case in which you have a specific dependence for the case of non-rigid types. Like, for example, if you say that, every boxer must have a specific hand, so you don't have to have a hand in all situations in which you exist, but you have to have that specific hand in the situations in which you are a boxer, a kind of the dicto version of this essential parthood. So, I mean,
it would interest me to see your documentation of how you deal with the permanent generic parthood case.
Okay, I'll send you the papers on that.
Good.
Barry. So I'll ask. So I still see no questions here in the chat. So people, please just either. Okay, so there is someone here, which is Joel Carbonera. I cannot see his hand raised, but thanks, Mona Lisa, for the heads up. So Joel, I think you can ask your question directly, orally.
Okay, thank you. Can you hear me?
Yep.
Yes.
Okay. Thank you for the very interesting presentation, Barry. And we have already found some problems regarding how to deal with non-existent objects. So I'm very curious about how to deal with this. And I like you to talk a little more about what is your approach for dealing with these non-existent objects. I think that I have lost some of the parts of your presentation regarding this point.
Good. So basically that you have to consider what goes on when a group of engineers are thinking about the differences between the aircraft that they thought they were buying, which is specified on a sheet of paper, or on a screen, which they can all see, and the aircraft that they've just tested. And they have a series of sentences about the aircraft that they've tested, which are all true and which are about really existing things. So the qualities, the temperature limits, the tolerances, and so forth. And then on the other piece of paper, they have the same sentences, but those sentences don't apply to any real aircraft. They apply to the idealized wannabe aircraft that the manufacturers thought they were building. And now what you have are two pieces of paper. Those two pieces of paper exist. They have very similar sentences on them, but those sentences are ontologically very different. Now, if you're going to be doing reasoning with those sentences about the two, so let's just, for the sake of simplicity, suppose that they are two aircraft that we're talking about. If you were doing reasoning, you would treat those sentences as being about certain things, and then you would get all kinds of consequences. But in fact, the first piece of paper is not about any aircraft at all. It's a useful piece of paper when it comes to comparing the operations of the aircraft you bought with the operations of the putative aircraft that you wanted to buy. But it's not useful as a description of any real aircraft, because it isn't a description of any real aircraft. It's not a description of anything. It's It's a specification. It's something which points to a future which we'd never realize, just like a plan. And the modal relation ontology allows you to explain why it is that those two pieces of paper look so similar, why the sentences look so similar, but why they are nonetheless ontologically to be treated very differently. And it allows you to make comparisons of a very important sort, which every manufacturer is making all the time, without making mistakes when you do reasoning ontologically. So it's not a hugely complicated discovery. It's a very simple trick, but the trick solves a hugely complicated problem in a way which we think is better than the standard way of solving it, which is to talk about possible worlds or other science fiction.
I think Parente has a question.
Hello, Barry. I have a doubt here.
Parente, sorry, your audio is very low.
Very low. Cannot hear.
Okay.
Positioning my mic here. Okay, can you hear me now?
Yep.
Okay. I have a basic question here related to the generically dependent continuant, right?
Yep.
And this kind of entities need a specifically dependent continuant to be concretized, right?
Yeah.
But my doubt is, anyway, being generically dependent continuant, something has to be conceived, right, by somebody, right? And that something is in the mind of somebody, right? My point is, how to concretize it? Isn't it necessary that something is already structured in the mind of this person who conceived this something? My point is how to, I mean, to concretize something. My question is not this already a little bit concretized in the mind of the person who conceived this pattern, this complex pattern, which is a generically dependent continuant?
Good. So the term concretized, we actually take from Roman Ingarden. Roman Ingarden was a Polish philosopher who wrote a masterpiece in 4 volumes about ontology. The problem is that he wrote it in German, and then it was translated into Polish. And it's only been, the first 2 volumes have now been translated into English. So I recommend the name Roman Ingarden to anyone who's interested in ontology. Now, Ingarden's major work, which was translated into English in the 70s, is called The Literary Work of Art. He's talking about novels. And he uses the word concretize in exactly the sense that you just described. The way you concretize a novel is by reading it, and then the events in the novel are concretized in your mind as you imagine the hero kissing the heroine and so on. And we borrowed that word and used it to describe not merely the case where a novel is concretized in the brain patterns of a reader, but also by the way it's concretized in the ink patterns on the page or in the pixel patterns on a screen. So I can't say more than that. Ingarden, I think, tells us something very important, namely, we're going to have concretizations of any sort only if some of them are in minds. So the reason why we have novels is not so that we can put these collections of paper and ink onto a shelf. The reason why we have novels is so that we can read them. And that's the raison d'etre of a novel. But once we have printed them, then we have concretizations in the form of ink. Anyway, that's all I can say. It's a terminological extension of Ingarden, which we find ontologically useful.
Yes. Can you say that it is a kind of, a new form of representation of something that was in the mind of
Absolutely, yes. That's why Tolstoy, when he was writing War and Peace, was not happy with it just being in his mind. He wanted it to be on paper so that other people could have the same concretization in their minds.
Okay, thank you.
Okay, thank you, Parente. I think Mara has a comment.
Indeed, very, very, very nice presentation. We always learn a lot, and indeed we need to the record of this talk to watch again, because many new ideas. I would like to make a comment about these non-existent entities, which is something that I frequently face when I am modeling. You know, one of the documents, the rule documents of the PPDM, which is the Petroleum Database Management Group, defines formally what's a well. The name of the document is what's a well. If you put in the internet, you can recover. It's a very good example for you to use in your talk. What they put in the definition of a well, they put like this: it's a real hole or a planned hole which has used for blah blah blah. How can something be a real hole and a planned hole? So it's exactly this example that he used here, because of course that they consider a well, even when it's in the stage of documentation for further development. But it's crazy in terms of the ontology, because you cannot be a whole and not be a whole in the same times. So it's interesting example for your presentation there.
Yeah, it's a very interesting example, and I think it provides a small amount of support for the strategy. So basically, there are two strategies. One strategy is to say, well, what they mean by well in the planned case is a future whole.
Of course.
But not every plan is realized. And so that future whole idea doesn't work. So I think that what they mean when they say well is
they mean many different things. I can
so
assure
what they
you.
mean by well in the case where there is no whole is that which, if everything goes well, is documented in this document. And then what they're really interested in is the document. And then, of course, the location, because the location is already there. And so they mean the location plus the stuff that doesn't exist, which is in this document. And so there are two real things here, the document and the location. In the future, they may be three real things, namely the document, the location, and the well. At the moment, there are just two. And now
quite weird to put this in a formal definition.
It's hard to express these matters. And so, and I've tried to do it without the cheat that the modal relation ontology brings. But I think that the modal relation ontology, it just makes everything honest. You talk about the well, but you don't talk about it in such a way that you can infer that it exists. You can talk about the location because it does exist. You talk about that using the ordinary relation ontology. But when you're talking about the well, because it doesn't exist, you use the well, or well number 316, but you say has location using the modal has, and then there's no way in which you can infer that that well exists.
Not so simple. I will send you the document. It's not too long.
It would interest me.
I think that you'll be very interested in taking a look, because you can see all these this problem related to the, and this is a formal definition of the association. That's funny thing. So, but I will let people talk with you.
So there's a question from Luis Machado,
And there are
which
questions actually here, Barry.
Yeah.
Do you mind if you go in order, or?
So I would like to deal with that Machado one first, because it's what I'm working on at the moment, but I couldn't read the whole question, so maybe he can speak. Or maybe you can read it to me.
I would like to ask if a total complex of dispositions, like a language, a religious faith, or a legal or price system, are generically or specifically dependent.
Okay, so first of all, we are working at the moment on a book about languages as total complexes of dispositions. So that's a very interesting topic from my point of view. And now we have a theory of a special kind of disposition, which is called a capability. And at the moment in BFO, we only have one documented subkind, namely function. But capability comes between disposition and function. So a function is a disposition an entity has, and which is the reason why that entity exists. So the screwdriver has the function of screwing screws because it has a disposition which we built into it. We designed it to perform that feature. That's why we say it's the function. A car has the function of carrying passengers. But my car has the capability to transmit music through its radio. But that's not the function of my car. It's the capability of my car. So capabilities are dispositions which I'm interested in the realization of, but which are not the function of the bearer. So it's not my function to digest food, but it's the function of my digestive system to digest food, and therefore I have the capability to digest food. Knowing a language is to have thousands and thousands of capabilities. And that collection, if we take all the people who have those capabilities, they create a gigantic aggregate of capabilities, which is the language in the view that we're defending. So a language is a collection of capabilities. A dialect is the sub-collection of the capabilities which form the language, which are spoken by the people who speak the dialect, and so on. And so all of these things are not generically dependent continuants. They are specifically dependent realizables, they're dispositions, but they're just gigantic, constantly changing aggregates of dispositions. And when we speak, we are realizing these dispositions. And when we listen, when we understand them, we're realizing these dispositions, because the capabilities are capabilities, not just to speak, but also to understand. And now the generically dependent continuants come into play in virtue of the fact that we can communicate, we can send messages, and what is communicated are generically dependent continuants.
Okay, so I think Sandro was here in line, Sandro Fiorini.
Yes, hello. Hello, Bersme. Thank you for the presentation. Very interesting. I would like to come back to the imaginary objects, which are very interesting. In Core Ontology, I don't know if you read it. I think maybe you read it. The Core Ontology for Robotics and Automation. At some point, we had to talk about designs using Sumo, by the way. But at the time, we were just thinking about designs without top-level ontology, and we came to the conclusion that, at the time at least, that design has the kind of design object. Like if you had a design of a plane, like you were talking about, you have this. You think about this imaginary object, and it kind of exists mentally, at least. At least your disposition towards the object, this mental object, is quite similar to this disposition you have toward the real object. And some of the description of this design object is similar to the description that you have of the real object. So at some point you realize that when you're describing then this imaginary object, this design, this plane, this imaginary plane, for example, you are using almost like a similar ontology that you are using to describe the real object, as I said. So my question to you will be, this design object exists in some way. It doesn't exist like the real object, like the real plane, but it does exist somehow. And then the question is, where in BFO this design object will be placed?
Yeah, so first of all, you have to remember that VFO is a pragmatic device. It's an artifact created to be useful. And there are going to be various constraints on utility. So if no one understands it, it won't be useful. And if can you turn your microphone down a bit? Okay, that's better. If no one understands it, it won't be useful. If everyone hates it, it won't be useful. If people always bring the same complaints against it, it won't be useful. And I know that because I've suffered under all of those forces over time. But gradually, it's becoming more useful, more people understand it, and so forth. Now, there are still complaints, and you just formulated one of those complaints, although you formulated it in a very polite way. BFO can't deal with those designed objects or thought objects or imagined objects because they don't exist. And so BFO, because it's a realist ontology, can't deal with them because it doesn't want to deal with them. But I'm assuming that you think that the only way in which you can do justice to the design process is by quantifying over or giving ontological commitment to designed objects. And so I talked a few minutes ago about Ingarden. Ingarden has exactly the same view. So he is a realist about imagined objects, intentional objects, and so forth. And I used to be a realist about those things also. But now, in order to be useful, you also have to be simple. And if you try, and I know this because I've tried to do it, and other people have tried, who invested many more years, have tried to do the same thing. And the result is almost infinitely complicated. If you really want to do justice to all the things that we can think about, which is a much richer group of entities than all the things which exist, then it will be a very complicated ontology. And if you want to see the result, you should look at Meinong. Unless you've already looked at Meinong. Meinong tried to do that job. And anyway, so what do I say? I say there are no such entities. Argument. All of the things, or many of the things which you think are similar, are not similar at all. For instance, mass, temperature, size, resistance, heat resistance, all of the things which apply to aircraft, which involve any kind of physics, don't apply to your designed object because the designed object doesn't have mass, it doesn't have temperature, it doesn't have heat resistance, because all of those things require material parts, they require molecules, and designed objects don't have molecules. So nearly all of the things that you say about the designed object and all the things that you think about the designed object are in fact modifications. They're strange counterparts of the things that we think and say about real objects. And how do we deal with that in a simple way in an ontology? Well, we just say the sentences look the same, but the meanings are quite different. And one way in which we can capture that, which is a cheap trick, is to use the modal relation ontology so that you block inference to existing entities. So they.
Okay.
Yeah, yes, I understood the point. I see that there are differences, but the examples you mentioned, just to make a point, actually you can say that a designed plane has a design mass. So they're quite similar in that sense. I mean, the difference, it seems to me that they don't exist. Yeah, right. You can talk everything you can say about the real object. It seems to me that you can say about the design object, apart from the fact they exist or not. Yeah.
Yeah, but now that's the way I used to think. That's the way people still think in medicine. So they think that if you have a false diagnosis, for instance, a diagnosis about a cancer when there is no cancer, then it's that you're talking about medically the same things, just they're the diagnosed cancer rather than a real cancer. But if you look at the ways in which those sentences connect up with each other, they're very different. So let me give you an example if I can think of one, a simple one quickly. So let's suppose you say aspirin treats headache. And now you have a new pill which is called gum aspirin, which is a chewable aspirin, but it doesn't work. But in the planning, you write gum aspirin treats headache, but now gum aspirin is never going to be produced. So it's the planned gum aspirin, but then the treats is never going to be a real treatment. It's going to be a planned treatment. And then let's suppose the headaches are real headaches. So we have planned gum aspirin, planned treats, real headache. That doesn't sound like a coherent sentence anymore.
Yeah, it's the problem.
Am I making sense?
Okay.
Yeah, yes, sure, yes. It's a difficult problem, but that we find every time we talk about plans and we talk about it, and that's what I'm finding, that the ontologies, the top level ontologies that we have today, even others than BFO, they don't help you a lot when you're defining like planned things. It's very difficult.
We have an active working group within the Industrial Ontologies Foundry, which is the design group. Are you involved in design in manufacturing?
No, not yet. Perhaps in the
have you
future.
heard of something called STEP?
It's a language, no?
It's a standard. It's a standard for design for design documents. In other words, for design. And we are working with them to try and find a way to use BFO as an ontology to make STEP more ontologically coherent. And we're dealing with exactly the problems that you are raising. So I really like the modal relation ontology, but I don't claim that it solves all the problems.
Yeah, it seemed like an interesting solution as well, but I'm just trying to understand it a bit more. Yeah. Thank you.
Okay, Sandro, thanks. I will give João Paulo the chance to ask a question, but let me just ask a really quick question, Barry. Is that how do you deal with future events? By using something similar like the modal relations on course? Okay. Okay, good. So you don't believe there are future events, right?
Not yet.
Okay, good. João.
Yeah, my question is related to the same issue of plans and designs and what you referred to as a trick in your solution in the modal relation ontology, which you mentioned this sort of copy what is there in the counterparts which are assumed to which exist. I was wondering how you could deal with a very common phenomenon, plans and designs, which is under specification, or when you have ranges of possible values and so on. Because then I say, you know, you can build this wall here and it can have between 1 meter and 1 meter and 20 centimeters and it's okay. Or you can build it and the color doesn't matter. I mean, there's no such thing as a physical object without color, but in the plan or in the design, the color is irrelevant.
Yeah, so I really think that the way to solve these problems, all of these problems, is to look at the two pieces of paper. The one piece of paper where you describe the real artifact and the other piece of paper where you describe your plan. And the piece of paper, it could be that you don't know the color of the real artifact also, or that you don't care, so you don't even bother to document it. I think that the parallels are quite similar. And so I'm not sure that there's any special problem resulting from what you described.
The problem I'm referring to is that if you're talking about the real world, you would say that every object has this quality, which is a color. But if you're doing a specification, then it might be optional to specify the color. I mean, there's a different constraints if you just copy this ontology about physical objects to this other.
No, I'm not suggesting that you go in the other direction. So the idea is that you you start with the planning documents or the design documents that we have, and you have to look at how we're going to interpret them ontologically. They are the problem. The physics documents or the real descriptions of real objects documents, they are not the problem. They'll contain falsehoods and errors and gaps, of course, but that's not a problem because the world can take care of itself. It's interesting, nearly all of these problems are dealt with at great detail by Ingarden, including in his book on literature, because he was pointing out that a work of literature always has gaps, but the real world never has gaps. And therefore the real world exists, but the fictional world is fictional. And therefore all idealistic philosophers are wrong because they're all describing a fictional world because all of their worlds are full of gaps. It's a very nice argument against most German philosophy, for instance. But just to finish your point, so it's the plans and the designs which are problems. You solve those problems by taking away the ontological presuppositions that they are misleadingly held to contain by just switching the relations that you're using.
Thanks.
It's so simple that it's almost sad.
Thanks.
Okay, I think we're going to have to wrap up soon, but let me use my role here and ask you a final question, Barry. I was told that you wouldn't be able to join this panel that we have tomorrow, so I'll ask the question that I would otherwise ask you tomorrow. So this panel is about it's about the next 10 years of ontology research. So I wanted to hear from you what you think are the opportunities, the missing, the really important gaps that we have to fill in the next decade of ontology research, and also the relation to threats. So for example, is machine learning rendering ontology research futile?
Good. All right. So first of all, the most important opportunities, I think, are where we were discussing yesterday: government catalogs, terminologies, taxonomies, and above all, government contracting or contracting in general. So contracts, very complicated contracts for big aircraft building projects or bombs or whatever it might be. They're ontologically very complicated. But because the government negotiators and the manufacturers don't have any shared ontology and are not required to care about the things that we care about, you end up with contractual delays, misunderstandings, and sometimes catastrophes. And so I think that the big opportunity for ontology is to try and simplify or remove the problems in the contractual negotiation by creating wonderful ontologies for all domains that contracts relate to, including contract law itself, of course. And there are people in the government in the US who are interested in this, so it's not a pipe dream. And then with regard to machine learning, so I don't know if I mentioned, but I did say that I'm writing a book a few minutes ago. 3 of the chapters in the book are about language as capabilities. The final chapter, those 3, is about why machine learning will never be able to speak a language in the way that humans do, because they will never have those capabilities. And that they will certainly never have the capability to build good ontologies. They'll be able to help to a certain degree in some areas, but they're not going to replace human beings for most of the interesting things that human beings can do. That's what the book is about. It's called There Will Be No Singularity.
Very good. Looking forward to reading that. And what about, the missing, let's say from a theoretical point of view, what do you think are the really important problems that we haven't solved that you expect to be solved in the next 10 years?
How to teach people to use ontologies properly. Well, I'm hoping it will be solved, but it certainly hasn't been solved so far. And the problem is that people always have the tendency to build their own ontologies because they try to learn UFO or Dolce or BFO, and they find it very, very complicated or alien, and so they think, oh, I'll build my own. That's one problem that we have to solve. But then even if they do think that they understand UFO or BFO or Dolce, they often don't. And so they build ontologies that look like BFO, but they're not really BFO.
Okay, unfortunately, I think we have to wrap up, but I see that there will be many questions that we won't have a chance to address here. Maybe you have the chance to take a look at this at Discord and reply to these questions afterwards. It's unfortunate, very unfortunate that we are not in Vitória. This will be the moment that we will give you a genuine gift from Vitória. Maybe next time. Hope to welcome you there.
So just tell me how I look at this Discord thing.
We'll send you the link.
Okay, good, good.
So on behalf of the community, thank you very much again for accepting this invitation. It was very nice to have you here.
Thank you all.
So
bye-bye.
Thanks again. Mona Lisa, do you want to say some final words before we break? Or Vitor?
We come back at 4, right?
Let's take a picture, please, please. I'd like to invite everyone to open your camera, please, for us to take a picture to record the moment. Okay? Victor, you capture, please?
Yes.
Okay.
Everybody look?
Yeah.
Okay. I think I've done it.
Very good.
Okay. Thank you very much, Barry Smith. It was a pleasure to have you here. Thank you all, and we will be back at 4 p.m. with the last session of the day. Thank you very much.